All right, welcome to solving quadratic equations. From here on out, we're going to do something a little bit differently. These explorations that you'll see at the beginning of your note-taking packet are actually going to be your warm-up assignments tomorrow during class. That's going to be consistent throughout the rest of the unit, so you do not have to complete them during the video. You're going to instead bring them with you to class, and you're going to be ready to solve them at the beginning of class tomorrow. And that goes likewise for exploration number 2. All right, when we get into the note-taking with the vocabulary, we're going to start with vocabulary terms that we're going to use for this particular lesson, and then we're going to follow that up with several examples in the extra practice section. Some of these you'll be doing on your own, some of these you'll be doing with me in the video. You just have to kind of go along with me and see how this all plays out for you. All right, so quadratic equation in one variable is the quadratic equation written in standard form or in vertex form, but in this particular case it's standard form, where x is the only variable because a, b, and c are coefficients, which will be numbers. The root and the zero of a function are both known as the solution. Another term you might see is also the x-intercept, so please be familiar with that as well. But the most important thing to remember is that roots, zeros, solutions, and x-intercepts are all the same thing. Today what we're going to do is we're going to take a look at solving quadratic equations by graphing, by using square roots, and by factoring. These are the steps that you're going to take to help you do that, and we'll go through each of these examples so you understand how that looks. Here's some additional notes that I'd like you to take based on what we're going to do today in our practice in this video session. Placing the quadratic function into y1 and placing 0 into y2 is an easy way for you to calculate the intersection between the quadratic function and the x-axis. It's a little bit easier than using the 0 feature of the calculator's calculate screen. Although we can look at that too if you're interested in seeing that one instead. Remember that all square roots have a plus and minus, so when you square root both sides of the equation, you're always going to end up with a plus or minus. And then when you're factoring, please remember to use your preferred method of factoring to simplify the quadratic from standard form, and then that's going to give you the two binomials that you'll set equal to 0 and then solve for x. All right, the property that you use once factoring is called the zero product property. And that basically states that if a and b are expressions, in this case they're going to be binomials, and they're both equal to 0 when multiplied together, then one or both of a and b can both be set equal to 0. And that's what we're going to use to help us solve by factoring for the rest of this unit. Okay, we're going to take a look at question number 1. And we're going to solve question number 1 by graphing. Now, the way we're going to do this is through the use of our calculator. So, into y1 goes our first equation, and that's going to be the quadratic itself. Into y2 goes the number 0, because that's going to give us the intersection of the quadratic and the x-axis. The next thing you're going to do is you're going to go in there and you're going to calculate the roots, the zeros, the solutions, the x-intercepts. And we're not going to use the 0 feature. Instead, we're going to use the intersect feature. It's just a little bit easier to go through. So I'm going to hit enter 3 times and get one of my solutions. The first solution I get is 3, 0. So 1, 2, 3, 0, I put a dot. The next thing I'm going to do is I'm going to bring that calculator back up again, and I'm going to calculate the other intersection point. Now, if I go ahead and hit enter, enter, enter this time, I'm just going to get that same value again. So that is not what I want to do. I instead want to move my cursor over so it's nearer to the other intersection point. And then I can finish out my cycle, and that's going to be 8 and 0. 1, 2, 3, 4, 5. 3 plus 5 is 8, so now we're set. In order to accurately graph this thing, I want to find its minimum point. So I'm going to go ahead and have the calculator calculate the minimum. That's number 3. And I want to move my cursor to the left side of where I think the bottom is. That's what that question is asking me, the left boundary. Okay, anywhere to the left will do. It says right boundary, so I'm going to move that cursor back to the right side of where I think the bottom is. And then I'm going to go ahead and have it calculate that minimum value, which is 5.5. This is a quirk of the calculator. And negative 6.25. So I'm going to go ahead and go over here. That's 3, 4, 5.5. And I'm going to count by 2's here. So 2, 4, 6.25 is about right there. And then I will draw my parabola like so. Now that I've gone ahead and done that, I'm going to give my solutions. My solution is going to be 3, 0, 8, 0, or because of the way that it's written, x equals 3 and x equals 8, and I bracket that. Or I write x equals 3, x equals 8, and box it in. So those are all acceptable responses to solving quadratics. What I'd like you to do right now is I'd like you to solve question number 2 on your own. Once the video is completed, you can either pause it now, fill it in, or come back after the video is completed and do that. Save 3 for tomorrow's class practice. All right, in question number 4, 5, and 6, our option is to use square roots. I'd like to do question number 5 with you right now. So much like absolute value, when we are using square roots, we are trying to isolate the squared term. So in order to do that, I must move the 19 to the other side of the equation. So I get 2k plus 3 quantity squared equals 100. Now that the value of the squared term is isolated, I square root both sides, and I get 2k plus 3 equals, remember there's 2 solutions, plus or minus the square root of 100, which is 10. Now just like absolute value, I'm going to write my 2 equations. That's 2k plus 3 equals 10, and 2k plus 3 equals negative 10. And I'm going to solve those side by side, make this problem, or to solve this problem easily. Subtracting 3 to both sides gives me 2k equals 7, and 2k equals negative 13. Divide out both sides, and I get k equals 7 halves, and k equals negative 13 halves. Box your final answer, especially since we have so much algebra going here. We want to be clear where our solution is, and that is how you solve by using square roots. Go ahead and solve question number 4 now, or after this video is concluded, and come prepared tomorrow to work on question number 6 with your group mates. All right, the last method we're going to use this today to help us solve quadratics is by factoring. I'd like to go ahead and look at question number 9 with you right now, and then you will be able to do the other 2 on your own. So I'm going to look at the squared term to determine which side of the equation I need to move all of my terms to. 5 is bigger than negative 1, so I'm going to go ahead and move x squared to the other side of the equation. And the 4x must go with it because everybody is going to the left side of the equation. What's left over here is 0, and what I have here is 6x squared plus 1x minus 1. I'm going to use the AC method to help me solve this problem. So remember, I multiply a times c. That's 6 times negative 1. That gives me negative 6. And I'm going to get those terms, those factor pairs, to add up to b, which is 1. So that's going to be negative 2 and positive 3. Now I'm going to split my middle term. So I get 6x squared minus 2x plus 3x minus 1. 4-term grouping gives me my groups of that I'm going to take out the greatest common factor of, and that's going to give me 2. What's left inside is 2x. What's left inside is 3x minus 1, and the GCF here is going to be 1. What's left inside is 3x minus 1. Now I'm going to use that property at the beginning of the notes to help me complete my last step, and that's going to be setting both of these binomials equal to 0 and solving for them separately. Subtracting 1 to both sides gives me 2x equals -1. Dividing both sides by 2 gives me my first solution of x equals -1/2. Adding 1, 3x equals 1. Dividing both sides by 3 gives me my second solution, x equals 1/3. And that's how you solve by factoring. At this point, would you please go ahead and solve question number 8, and tomorrow be prepared to share and work with your group mates on question number 7. In addition to those problems, we'll be working on questions number 10 and 11 tomorrow in class. So if you have time now, go ahead and get started on them so that you can be prepared to share with your group mates. Otherwise, be ready to work on those tomorrow once you get in class.